MITRE Corporation has unveiled its annual compilation of the most critical software weaknesses, outlining the top 25 vulnerabilities for 2023. This comprehensive list is based on an analysis of public vulnerability data in the National Vulnerability Database, (NVD), over the past 2 years, mapping root causes to common weakness enumeration, (CWE), weaknesses. Here are the details of each vulnerability from the top 25 dangerous software weaknesses of 2023. 1. Out-of-bounds write, CWE 787. This vulnerability occurs when an application writes data outside the bounds of a memory buffer, allowing attackers to inject malicious code. 2. Cross-site scripting, XSS, CWE 79. This vulnerability happens when an application fails to properly sanitize user input, enabling attackers to inject malicious code into web pages. 3. SQL injection, CWE 89. This vulnerability occurs when an application fails to properly sanitize user input used in constructing SQL queries, enabling attackers to inject malicious SQL code. 4. Use after free, CWE 416. This vulnerability occurs when an application fails to release memory that is no longer in use, allowing attackers to access and manipulate the memory for malicious purposes. 5. OS command injection, CWE 78. This vulnerability occurs when an application fails to properly sanitize user input used to execute operating system commands, allowing attackers to inject and execute malicious code. 6. Improper input validation, CWE 284. This vulnerability occurs when an application fails to validate user input correctly, enabling attackers to inject malicious code into the application. 7. Incorrect default permissions, CWE 264. This vulnerability occurs when an application grants excessive permissions to users or processes, allowing attackers to gain unauthorized access to the system. 8. Server-side request forgery, SSRF, CWE 918. This vulnerability occurs when an application fails to validate user input used to construct HTTP requests, enabling attackers to force the application to make unintended requests. 9. Improper restriction of operations within the bounds of a memory buffer, CWE 787. This vulnerability occurs when an application fails to restrict operations within the boundaries of a memory buffer, enabling attackers to inject malicious code. 10. Path traversal, CWE 22. This vulnerability occurs when an application fails to properly restrict user input that traverses directories, allowing unauthorized access to sensitive files. 11. Unrestricted upload of file with dangerous type, CWE 434. This vulnerability occurs when an application allows users to upload any type of file, potentially allowing the execution of malicious files. 12. Improper neutralization of special elements used in an OS command, CWE 78. This vulnerability occurs when an application fails to neutralize special elements in operating system commands, enabling attackers to inject and execute malicious code. 13. Improper authentication, CWE 287. This vulnerability occurs when an application does not properly authenticate users, allowing unauthorized access to the application or system. 14. Improper authorization, CWE 285. This vulnerability occurs when an application does not properly enforce access controls, enabling unauthorized actions by attackers. 15. Improper input validation for XML external entity, XXE, CWE 601. This vulnerability occurs when an application fails to validate user input used to construct an XML document, enabling attackers to load external entities and exploit other vulnerabilities. 16. Improper restriction of XML external entity reference, CWE 666. This vulnerability occurs when an application does not properly restrict references to external entities in XML documents, enabling attackers to load external entities and exploit other vulnerabilities. 17. Use of hard-coded credentials, CWE 327. This vulnerability occurs when an application utilizes hard-coded credentials, making it easier for attackers to obtain the credentials and gain unauthorized access. 18. Improper validation of array index, CWE 771. This vulnerability occurs when an application does not properly validate the index of an array, allowing attackers to access or modify data outside the boundaries of the array. 19. Improper input validation for regular expressions, CWE 829. This vulnerability occurs when an application fails to properly validate user input used in constructing regular expressions, enabling attackers to inject malicious code. 20. Improper encoding or escaping of output, CWE 692. This vulnerability occurs when an application does not properly encode or escape output, allowing attackers to inject and execute malicious code when the output is viewed. 21. Improper neutralization of input during web page generation, CWE 905. This vulnerability occurs when an application fails to neutralize input during web page generation, enabling attackers to inject malicious code into the web page. 22. Improper input validation for dynamically generated content, CWE 802. This vulnerability occurs when an application fails to properly validate user input used to construct dynamically generated content, enabling attackers to inject malicious code. 23. Improper restriction of file access, CWE 264. This vulnerability occurs when an application does not properly restrict user access to files, potentially allowing unauthorized access to sensitive files. 24. Improper restriction of functionality, CWE 731. This vulnerability occurs when an application does not properly restrict user access to certain functionality, enabling unauthorized actions by attackers. 25. Incorrect calculation of buffer size, CWE 122. This vulnerability occurs when an application does not correctly calculate the size of a buffer, potentially leading to buffer overflow and exploitation of other vulnerabilities. These vulnerabilities pose significant risks to software systems, and organizations should prioritize addressing them to enhance their security posture and protect against potential cyber attacks. Thanks for watching the video. Please like and subscribe to the channel.